So some relatively simple properties of vectors. Two vectors are equal if they have the same length or the same magnitude and they're parallel. They go in the same direction. They don't have to start at the same place and they don't have to end at the same place. And that's one of the powerful things about vectors is you take away location, starting location, ending location, and just deal with what's happening. And in both of these ones, we're going 4 to the right and 5 up. 1, 2, 3, yeah, 4 to the right, 5 up. So they'll have the same length and the same direction. That makes them equal. If they go in opposite directions, we call them negative vectors. D to E is equal to negative F to G. So if one goes one way and the other one goes the other way, but they're the same length, we call them negative vectors. And if you multiply a vector by a scalar, we get a parallel vector that is just longer or shorter than the first one. So are these ones parallel? Well, if they are parallel, I mean, in our old math, we would have shown the slopes are the same. In our new math, we're sort of doing the same thing. We're just showing that they're equal to each other, but they're equal some scalar that makes them equal. So if we look at this, DE is 2 times A to B. If we actually look at the numbers, A to B is 4 right, 5 up. D to E is 8 right, 10 up. And you could write 8, 10 as 2 times 4, 5. So as far as scalar multiplication goes, when there's a number in front of a column vector, that number would multiply both the x-coordinate and the y-coordinate. So on the next page, you've got little vectors there, A and B. And then all of the other ones, I want you to write in terms of A or B. So A is 2, 4, and B is 2, negative 1. C is negative 6, 3. Can you see that that is negative 3 B's? Because B is going in this direction. It's in the same direction as B, but going, it's in the same slope as B, but it's going in the opposite direction. D is a half of A. E is negative 5 B's. And F is 2 A's. How are A and B related? Well, the slope of A is 2 over 1. The slope of B is negative 1 over 2. These are negative reciprocals. And we get to learn a new word for perpendicular, orthogonal, right? Because it kind of rhymes? No. Okay. So which of these vectors are going to be parallel with 7i plus j? So we could write that as a column vector. And notice how our column vector is really closely related to our slope. So in each of these, we could think, what is the slope? Well, the slope is just the flip. You're not making it a negative reciprocal, but you are making a reciprocal. So if we do the reciprocal of each of those, simplify them, we can find out which ones are exactly 1/7, and then those ones are all parallel to that original one. In other words, they can all be written as a multiple of that original one. Find the value of t so that the following two vectors are parallel. So if the vectors are parallel, we know that one is a multiple of the other one. And again, you can write these as column vectors. And we can say, well, if 8 over t is equal to k times 20 over negative 16, or you could put the k on the other side. It doesn't really matter which side that you put the k on. What you can do with this is you can say, well, I need my x values to be the same. And if I make my x values the same, I can solve and find out that k would be 2/5. Well, if k is 2/5, I can make my y values the same, plug in 2/5 for k, and now I can solve for t. But this is the idea. The idea that if two are parallel, then one is just a multiple of the other one. It doesn't matter where you put that k. You could have gone k times the vector r is equal to s and solve it that way. You'd get a different value of k. You'd probably get 5/2 rather than 2/5. But either way, you use that idea and you can solve, right? Or you could also solve this just using slopes. The slope of r is t over 8. The slope of s, negative 16 over 20. And then just use cross multiplication and your algebra skills to solve for t, and you get the same answer. So what we're sort of starting to move towards is we start to recognize how vectors are related to slopes and to lines. And one of the things that we do in this unit is redefine everything we learned from grade 10 linear algebra, equations of lines, with vectors instead of coordinates and points. And you can do the same idea in 3 dimensions. So if we write these as column vectors, and sometimes it's really easy to see what k is. Which coordinate will tell you what k is? The x, the y, or the z? The y. In fact, once you distribute the k in, it already tells you from your y coordinate that k has to equal -5. Well, if you know that, you can solve for t, and you can solve for s. S is not a good letter to use. You thought it was a 5. Here, we'll make it. Is that nicer? Yeah, because everybody's like, how did you get 5 times -5 to be? Yeah, no, this is the s. Fancy. Oh, that's a 5. Crap. There we go.